Every moment of every day, Earth is spinning on its axis at an incredible speed, carrying us along without us even noticing. At the equator, this rotation reaches over 1,000 miles per hour, yet we go about our lives completely unaware of this rapid motion. It's a phenomenon so constant and smooth that it feels as if we're standing still. But what would happen if, in an instant, the planet came to a sudden stop? This thought-provoking scenario opens the door to a series of dramatic and unexpected consequences. If Earth were to stop spinning abruptly, the immediate consequences would be catastrophic. Due to inertia, everything not firmly anchored to the planet's bedrock would continue moving at the same speed as Earth's rotation, over 1,000 miles per hour at the equator. This sudden jolt would send buildings, vehicles, oceans, and even the atmosphere hurtling eastward, resulting in widespread devastation. The force would flatten structures, uproot forests, and generate massive shock waves across the surface. In an instant, the world as we know it would be transformed by unimaginable destruction. Winds reaching speeds of over 1,000 miles per hour would unleash unimaginable destruction across the planet. Entire cities would be flattened in moments, as buildings, bridges, and infrastructure stand no chance against such force. Anything not firmly anchored to the ground would be swept away, leaving landscapes stripped bare. The sheer power of these megawinds would erase familiar landmarks, transforming urban and rural areas alike into featureless expanses of debris. In the aftermath, little would remain to indicate the world that once was. If Earth's equatorial bulge were to disappear, the planet's oceans would be thrown into chaos. Without the bulge, the gravitational balance that keeps water concentrated around the equator would vanish. This sudden shift would cause vast amounts of ocean water to surge toward the poles, overwhelming coastlines with immense force. Massive tsunamis would sweep across continents, inundating cities and landscapes far from today's shores. The redistribution of water would reshape the planet, leaving devastation in its wake. Mega tsunamis are among the most powerful and destructive natural disasters on Earth. Unlike typical tsunamis, these colossal waves can reach heights of hundreds of meters, traveling at incredible speeds across entire oceans. When they strike, the force is so immense that entire coastlines, cities, and even whole countries can be obliterated within moments. The sheer scale of devastation leaves little time for escape, erasing landscapes and communities in an instant. Such events serve as a stark reminder of nature's overwhelming power and the vulnerability of human civilization. Without the usual forces that keep our atmosphere in check, the air would begin to move chaotically, unleashing powerful superstorms across the planet. Winds would accelerate to unimaginable speeds, tearing through landscapes and reshaping coastlines. The sky itself would become a relentless force of destruction, filled with swirling clouds and violent weather patterns. These unstoppable storms would make the surface of the Earth nearly uninhabitable, as the atmosphere transforms into a constant, unpredictable threat. Powerful winds have the capacity to remove the top layer of soil, a process known as soil stripping. This loss of fertile soil can severely disrupt plant growth, making it difficult for vegetation to take root and thrive. As a result, entire ecosystems may become destabilized, with habitats for insects, birds, and small mammals diminishing. Over time, this environmental damage can lead to reduced biodiversity and increased vulnerability to further erosion and land degradation. Imagine a world where a single day stretches across an entire year. One side of the Earth is bathed in relentless sunlight, enduring months of scorching heat and unending brightness. Meanwhile, the opposite side is shrouded in perpetual darkness, facing freezing temperatures and an absence of natural light. This dramatic shift creates extreme conditions, challenging the survival of plants, animals, and humans alike. The familiar rhythm of day and night is replaced by a stark divide, fundamentally altering life as we know it. With perpetual daylight on one side of the planet, temperatures would rise dramatically, creating an environment far too hot for most forms of life to survive. The constant exposure to the sun would prevent any cooling, turning the landscape into a scorched, barren wasteland. Meanwhile, the dark side, deprived of sunlight, would experience a relentless drop in temperature. This side would become frigid and inhospitable, with any existing water or atmosphere likely freezing solid. The stark contrast between these two extremes would make it nearly impossible for life as we know it to thrive on either side. Earth's magnetic field is generated by the movement of molten iron within its outer core, a process driven by the planet's rotation. This dynamic action creates a protective shield that deflects harmful cosmic radiation and solar winds. If Earth's rotation were to stop, the core's movement would slow dramatically, causing the magnetic field to weaken or even collapse. Without this shield, the planet would be exposed to increased levels of dangerous radiation from space. Such exposure could have serious consequences for life on Earth, affecting everything from electronic systems to the health of living organisms. When solar radiation intensifies, it can have a dramatic effect on a planet's atmosphere. High-energy particles from the sun bombard the upper layers, gradually eroding the protective gases that surround the planet. As the atmosphere thins, it becomes less effective at shielding the surface from harmful radiation and extreme temperatures. This process makes the environment increasingly inhospitable, with conditions that can no longer support life as we know it. Over time, the loss of atmospheric protection exposes the surface to even greater dangers from space. Earth's appearance would be dramatically altered, with water migrating toward the poles and leaving the equator barren and dry. The once lush tropical regions would transform into endless deserts, stretching across continents where rainforests and jungles once thrived. In contrast, the polar regions would swell with vast new seas and lakes, creating unfamiliar coastlines and submerging land that was previously covered in ice. Ecosystems would be forced to adapt or perish, as plants and animals struggle to survive in these extreme new environments. The familiar map of our planet would become almost unrecognizable, reshaped by the relentless redistribution of water and the shifting balance of life. Survival in such harsh conditions would become nearly impossible for most forms of life. The majority of species would face extinction, unable to cope with the dramatic changes in their environment. Only a handful of organisms, those capable of adapting to extreme heat, cold, or scarcity of resources, might endure. These survivors would likely be resilient microbes or extremophiles, thriving where more complex life cannot. The planet's rich biodiversity would be reduced to a few remarkable examples of adaptation against overwhelming odds. In the aftermath of a catastrophic event, the question arises, could anything survive? Some forms of life, known as extremophiles, have demonstrated remarkable resilience in harsh environments, suggesting that certain microorganisms might endure even the most severe conditions. Humans could potentially find refuge in underground shelters, where they would be protected from extreme temperatures and radiation. Additionally, the twilight zone, the narrow region between perpetual day and night, might offer a temporary haven with more moderate conditions. Survival would depend on adaptability, resourcefulness, and the ability to create controlled environments in an otherwise hostile world. If humanity were to face such a transformative event, survival would come at a significant cost. The very fabric of civilization would be altered, reshaping our societies, cultures, and daily routines. Familiar comforts and established norms might vanish, replaced by new ways of living and interacting. The collective experience would leave a lasting imprint, ensuring that humanity could never return to its previous state. In this new reality, adaptation would become essential, fundamentally redefining what it means to be human. Earth's rotation plays a vital role in shaping the conditions necessary for life. It drives the cycle of day and night, influences weather patterns, and helps regulate temperatures across the globe. Without this constant spin, the planet would face extreme climate changes, devastating storms, and prolonged periods of darkness or sunlight. Such disruptions would threaten the survival of countless species, including humans. The steady rotation of Earth is not just a cosmic detail, it is fundamental to the balance and stability of life as we know it. Exploring the wonders of Earth's rotation reveals just how interconnected our daily lives are with the rhythms of our planet. From the rising and setting of the sun to the passage of time itself, Earth's steady spin shapes the world as we know it. Staying curious about these natural phenomena deepens our appreciation for the science that surrounds us. For those eager to continue this journey of discovery, there are always more fascinating topics to uncover in the world of science.